Hey guys, welcome back to my YouTube channel. I'm now just continuing the Year 10 videos for the half-yearly exam revision. In this video, we're just going to start off with question 14, which is, when corrosion happens to a metal, what atmospheric gas does it combine with? Well, that's a very, very simple question. Any corrosion reaction requires oxygen as the reactive gas. So oxygen loves combining with metals, and that reaction is called a corrosion reaction. Question 14 now, this is a little bit difficult, and this is based upon the practice that we did in class where we mixed two aqueous solutions, which are substances that have been dissolved into water, and then once we mix them together we form the solid precipitate. So this question is just asking us, and it's giving us a set of rules, and it is asking us which one is the precipitate in the reaction or the solid in the reaction. So let's interpret this table here. So the first thing it says is compounds that are soluble. Group 1 compounds, meaning all the elements in group 1 mixing with other compounds. Nitrates, anything that mixes with a nitrate. A chloride and an iodide, anything that comes together with a chloride and an iodide, and anything that comes together with a sulfate. Now, as you can see here in this section, it says except for Ag plus and Pb plus. So what are Ag and Pb? If I get the periodic table, Ag, which is located right here, is silver, and Pb is lead. Okay, so what it's saying here is if I have silver chloride or silver iodide, this is an exception of the solubility. So in other words, it's no longer soluble. It'll form into a solid. So silver chloride or silver iodide will form solids. Lead chloride or lead iodide will form solids as well. And also here it says Ag sulfate, so silver sulfate or lead sulfate or barium sulfate, calcium sulfate, all of those form solids. Anything else that's not in here, however, will not form a solid. So if I have, for example, let's just say we have calcium there. If I have magnesium sulfate it'll be soluble. Okay, it will dissolve in water. On this side of the table, it tells us compounds that are not soluble, meaning these ones don't dissolve. Carbonates, except for anything that mixes in group 1 here. Phosphates, same thing. Hydroxides, same thing, and barium and calcium. Oxides, so anything that ends with oxide, hydroxide, phosphate, blah, 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 except for anything in group 1 mixed coming together, okay? So in this question 15, it is copper nitrate plus sodium hydroxide. So imagine having two aqueous droppers, and we drop them into in a test tube. We're going to have copper hydroxide and one other compound there. So these are the reactants and these are the products. So as you notice, the copper hydroxide, so what's happening is copper nitrate plus sodium hydroxide. Let me just write that down. Oops, plus sodium hydroxide. Just gonna, there. We have one part of the question which is copper hydroxide. So the copper mixed, it took the place of the sodium there. So we have copper hydroxide. What needs to happen now is the sodium needs to take the place of the copper. So we now have sodium nitrate. Okay? Okay, now the next part of the question is asking us what is in the blank space. We've already answered that. And which of the products are soluble. So we're seeing which product dissolves into water. Something that is not soluble, once again, is a precipitate. It forms the solid, okay? Which one of these dissolves? Which one is soluble? We need to go back to the solubility rules table. So we have a nitrate and we have a hydroxide, okay? We have nitrates here and hydroxides, which are here, okay? So let's go to the first part, which is the copper hydroxide. Copper hydroxide, it says compounds that are not soluble, meaning they form the precipitate or they don't dissolve into water. Any hydroxide, every hydroxide except for elements in group 1. So we don't have lithium sulfate or sodium sulfate or potassium sulfate or rubidium sulfate. We have sorry, not sulfate, hydroxide, my bad, hydroxide. We have copper hydroxide, okay? We don't have any elements in this group here. We also don't have barium or calcium. So therefore, this is a solid, okay? The sodium nitrate. Now we have to assume that this is the precipitate. But how can we prove it? Let's go back to the solubility rules table. We have the nitrates right there. Compounds that are soluble. Any nitrate, every single nitrate, no matter what it is, no matter what group it is going to be soluble. Meaning it's never ever going to form the precipitate. So this, therefore, is soluble. Okay, answering the next question now, which is question 16. Which of these compounds is a blue, insoluble solid? Meaning this cannot dissolve into water. Calcium hydroxide. Calcium is white. Calcium nitrate. All nitrates dissolve, okay? So all the nitrates, they dissolve. So even if this was blue, it wouldn't been able to be an insoluble solid, okay? Hypothetically. The next one is copper nitrate. Copper nitrates, remember all nitrates, they dissolve. So therefore, the copper hydroxide is our blue soluble, insoluble solid. Okay, so how do I confirm that this copper hydroxide is a solid? Just to double check, let's go back to the solubility table. The hydroxides, the only time where they're not soluble is if they're in group 1. Copper is not in group 1. It's in the transition metals, and we got barium and calcium hydroxides, and we don't have that. We have copper hydroxide. So that is just confirming the question. And that concludes the chemistry part of our first page, and I'll just stop it there so we can continue the questions.